In this lecture, we're going to do the static analysis of the same model that we did in the previous chapter, but this time we're going to treat this model as a beam. So let's go to simulation and let's go with new study. Let's go with static study and let's put a name here, beam. Let's click OK. Now in the first step we have to define the material, so let's go to truss, right click and apply material to all bodies. And we're gonna go with aluminum alloy 1060 and let's click apply and close. Now let's open this truss here, cut list, this tube and this tube. And now we have to treat those bodies as beams. So let's go right click on the first one, this one, and here we have an option treat as solid, and this is not what we want. So now let's go to edit definition, and here we have a type beam, and this is what we want. Here we have end 1 connection and end 2 connection. If we choose beam, then we can control the connection at each end of every element. So we can control the transfer of forces and moments at each end. Those forces and moments at those ends can be set to 0. So in general, we can restrain each end of the beam. Here we have options rigid, hinge, slide, manual. If we choose rigid, then we have a full transfer of the forces and moments. If we go with hinge, then end can rotate freely and we can transfer moments, only forces. If we go with slide, then we can transfer forces. And here we have manual as well. If we choose manual, then user can specify for the moment of force if it will be 0 or not. In our cases, we're going to choose rigid for end 1 connection and we're going to choose rigid for end 2 connection. Here we have section properties. Let's open this. Here we can override the torsional constant, the distance for maximum shear stress, and this is the distance from the center of the section to the point of the maximum torsional shear. And it depends on the cross section. And here we have a shear factor. Shear factor we use for a stress calculation, and this is the ratio of the effective area under shear and beam's cross-section area. Now we're going to choose everything as it is and let's click OK. So all elements we want to treat as beams. And for all elements we want to choose rigid connection and ends. So we can right click on the second one, edit definition, and we have rigid, rigid and beam. And by default we have the same for those two. In the next step we have to recalculate the joints. So when we calculate the joints, the program creates a node at each center of the cross section of each joint member. So let's go to joint group, let's go edit, and here we see that here we have 2 joints. And this is not what we want. So we're going to choose here select, and we're going to unselect this one, and we're going to select again this one, and let's click calculate. And now we have only one joint here, and this joint is the intersection of those 4 elements. And here we have a joint at each free end. And now let's click OK. Let's go with OK. And now we have to define fixture. And the fixture will be applied at the free end of each structural member. And we're going to use those joints that we have calculated. So let's go to fixture, fix geometry, and let's choose those 4 joints. Now let's click OK. In the next step, we have to define loads. We're going to have 3 different loads. We're going to have gravity, torque, and non-uniform load. So first, let's go with gravity. Right click, gravity. We have top plane, and let's click just OK. And this is our gravity. Now let's go right click. Let's go with torque. Here, let's choose a joint. And let's choose this joint here. Now let's go here to our moment. And let's go with 80 Newton meters. Let's go with reverse direction. Let's click OK. Okay, we have a problem. We have to select the reference plane. Okay, let's select here and let's choose top plane like this. And now let's click OK. And the third load will be non-uniform load. So let's right click here. Let's go to force. So this non-uniform load will be applied to the beam. So here we're going to choose beam and we're going to choose this beam here. Like this. And now let's go with non-uniform distribution. Let's check this. Let's go down. And here we have three options. We can go with triangular distribution, we can go with parabolic, and we can go with elliptical. We're gonna go with parabolic distribution, and here we can choose total load distribution, center load, and table driven load distribution. Total load distribution distributes the total force moment along the length of the beam. There are no loads applied at the ends of the beam. If we go with centered load distribution, then we have force moment at the center of the beam, and the loads decrease on each side of the center according to the selected triangular, parabolic, or elliptical distribution, in our case with parabolic distribution. And the last we have table-driven load distribution. It distributes the force values at a specific location along the length of the beam. That location can be specified as a percentage or as a distance from the end of the beam. But we're gonna go with total load distribution. Now let's go here, and let's now select a plane for direction. And let's go with front plane. Now let's choose here our force, normal to plane, and this will be 200 newtons, like this. And let's click OK. And this is our first load distribution. Now we have to create a second non-uniform load. Let's go to external loads, force. Let's go here with beam, and let's choose this one. Let's select the plane for direction. Let's go with front. Let's go with non-uniform, and let's go here with parabolic. And here we have our force 200, like this. And let's click OK. And now we have defined our loads. And in the last step, we have to create a mesh. So the number of the elements will be defined automatically, but we can also change them. We can also use apply mesh control. So let's go here to the mesh, right click, and let's create a mesh. Like this. And now we see that the meshed members are displayed as a hollow cylinders. As well, we can apply mesh control. So let's go right click, apply mesh control, and we can control our mesh by number of elements or by changing the element size. So let's choose this element. Let's go here, element size, and let's go with 3 millimeters. Like this, and let's click OK. And now we don't see any changes because we have to go here, right click, and create a mesh again. And now we can see the changes. Here we have much more elements than here, and here. And now we are ready to start with our analysis.